Hello everybody, this is Manveen Kaur, the team leader of Group 5B from ITB, and the topic is Impact of Climate Change on Birds Using Deep Learning, Neural Regression Analysis. Our group guide is Mrs. G. Lavanya and our team members are Keshika Reddy and Thrichana Reddy. Coming to the abstract, we all know how climate change affects humans, birds and animals alike. So climate change is impacting birds by altering their habits and migratory patterns. So in this project, we have used data from countries like the UK, the US and various parts of Asia. And with this data, we have then used a neural regression analysis to predict future bird counts. So that's what our project is about. Now, the existing system consists of bird species identification using deep learning. So this first project employed convolutional neural networks, which is basically identification of images of birds. And the second project is about climate change detection using machine learning that employed two algorithms, random forest regressor and XGBoost regressor. So that's a simple regression project. But as you can see, the existing systems don't exactly match our project statement, although they are similar. That is because the data set that we have used is completely new. Each record that we have collected has been done by us individually, and we have not used platforms like Kaggle. Now I'm going to show you the data set. So these are the three sheets that we have collected the data for. First one is UK, the second one is the US, and the third is for various parts of Asia. So we have collected data for over 95 species of birds. So for each species, we have over 100 years of data. And as you can see, from 1920 to 2022, we have collected the data for each species. And we have attributes like precipitation and temperature to determine the future bird counts. And for the precipitation and temperature, we have the corresponding bird count as well. So we've done this for UK, Asia and US as well. Coming back to the PPT. So this was about the existing systems and our data set. After this, the proposed system. The proposed system, as I had earlier said, is basically that we have collected data set from UK, US and various parts of Asia. After that, we are going to visualize the data using box plots, histograms, etc. And we have also pre-processed the data using standard scaler. And after that, we have employed neural regression analysis, and we have used attributes like temperature and precipitation to predict future bird counts. After that, an interface was also created to view the corresponding image of the temperature and the precipitation entered. So I will show you in the execution later how you will enter a precipitation and temperature value, and corresponding to that, the image of a bird would be displayed. Coming to the UML diagrams, we have the use case diagram that consists of data collection analysis, data pre-processing, training the model, identification of bird species, predicting the outcome, determining statistical impacts on birds, and after this project is over, we can develop mitigation plans and monitor and evaluate impacts. After this, we have the sequence diagram that consists of objects like user, model, data pre-processing, training, and prediction, and the process is the same as the UML diagram. After that, we have the activity diagram that has steps like collecting the data, pre-processing the data, dividing the pre-processing data into testing data and training data, and after that the data is tested and evaluated on the model, and if the model is good enough, go ahead, but if it is not, train a new model or make further changes to your current model. The data flow diagram is similar. Now we have start, data collection, data pre-processing, testing the data set, training the data set. So it is split into those two, and after that the data is tested and evaluated on the model, and if it is accurate enough, go ahead and predict the outcome, but if it is not, choose a better model or make enhancements to the current model to get a better accuracy. After that, we have the architecture diagram that consists of data collection as the input, data cleaning and pre-processing, and then training and testing the data using neural regression analysis, predict the data, and after that visualize the data, calculate the R-square score because it's a regression project, and then give the output. Now coming to the code and execution. I am going to open the Jupyter file now that consists of my code. I am going to execute the code side by side. Here I have all the libraries imported for this project. I'm going to explain as their usage comes in further in the code. So I'm going to execute this using Shift plus Enter. And it's an Excel sheet. And we have printed all the sheet names here. After that, we have printed all of the bird names, precipitation, temperature, and bird count values of all the 3 sheets over here to visualize the data basically. So let's execute the Excel file and let's execute this part. Okay, now that it has been executed, let's move on to the next step. As I had said, we had collected 95 species of bird data. So we have a total of 10197 rows, and this each row was collected by all the team members manually. So the next step is to individually print all the bird species for each country. Execute this, and for UK we have collected 53 species according to the output. Asia we've collected 15, US we've collected 29. Now let's print all the graphs of the bird count versus the year for all the 3 sheets. Shift plus enter, shift plus enter, and shift plus enter. So these 3 are you have and analyze how much missing data that you have in your data set. But since it is a data set that was created by us and not taken from various sources like Kaggle, we have made sure that there was no missing data in any of our rows or columns. So as you can see, it is crystal clear that we have 0 missing data. Before that, we had executed the graphs. So these are the graphs of the bird count versus the year. So this is for data visualization. Now coming to other types of data visualization techniques, those are constructing box plots and histograms, as we have done over here. Box plots, we had constructed these just to see how many outliers we have in the data. And as you can see, we do have many outliers in the data. All these dots and circles, these are all outliers that have to be dealt with properly or removed. And in the next step, we have our histogram, and this was constructed just to see how well our data was distributed. So as you can see, some of it is well distributed, but some of it, like this one, frequency versus bird count, that is not well distributed. So that means we need to do something like scaling, or we need to normalize the data in order to prevent all this, because this might cause errors after the training and it might reduce the accuracy. So after that, we have combined all of our sheets, and now we are using the scaling technique known as z-score in order to scale our data. Over here, I have scaled precipitation and temperature, and after this, I have scaled my bird count too. So this is the final scaled data. Now, so this is the scaled value, and you have 10,000 rows, 10,000 plus rows. Now you divide your data set, you split your data set into 2 parts, training and testing. You have, for testing, you're using 0.3, and for training, you'll be using 70% of the data. So the most important part of the project is neural regression analysis. So I had worked for a long time to determine which combination of layers were the best for this project, and finally I came up with this code. This 4 layers were perfect for my code to give me a better accuracy. And first layer has 128 neurons, 64, 32, and 1. And after that, my activation functions are rectified linear unit for the first 3 layers, and for the last layer I have used linear. And I'm also using regularizers in order to prevent overfitting of data. So this finally is my architecture for my neural regression analysis project. So based on this, I have predicted my future bird counts using precipitation and temperature values. Now let's execute the data. Okay, so the last executed part was this graph. Now missing data, let's execute this, all of this. I'm pressing shift plus enter to execute my data. So I have executed everything up until this part. So let's execute the architecture. The architecture has now been executed. Now execute the training part of it. I am using 100 epochs, which means 100 iterations, and my batch size is 500. And I'm fitting my model over here. And as you can see, the loss that has occurred because of this architecture is really low. So this is the ideal architecture that I'm going to use. I'm not going to add more layers because it will add more complexity to it, and it will cause overfitting. But if I remove number of layers over here, and I only use maybe 2 layers, it will give me the wrong accuracy, because it will not be able to capture the complexity of the data. It will not be able to capture the underlying patterns that are there in my training data set. After that, I'm using custom temperature and precipitation values, and I'm predicting the bird count based on the training data. Let's execute that. And after that, I'm scaling, and I am transferring all the scale data for my predictions. So executing that. Now you get the bird counts. These are my bird counts, and to visualize them, I have constructed various graphs like predicted bird count versus custom temperature. So over a period of time, I had analyzed all this data. So if you can see, if you do a quick Google search, you will get to know that the ideal temperature for birds to survive and thrive on is between 5 to 25 degrees Celsius. And after that, the birds can survive after that temperature also, but they start decreasing very, very gradually. So as you can see, my graph is coming down a little bit after 25 degrees Celsius. And as for precipitation, the bird count increases with increase in precipitation, because when precipitation is increased, their habitat also increases, like forests and trees and all of that. And as you can see, over the years, after this is a prediction that is done for the years after 2023, you can see that at the end, the bird count is decreasing. So this is my final analysis of the data set and the predicted bird counts based on neural regression analysis. After that, I have calculated my R score. Gradio, import Gradio as GR, that was there in the first step. It is basically a Python library that is used to create interfaces in my Jupyter notebook. So using that, what I have done is I have created, one second. Yeah, so this has executed. I've created this interface. So if you toggle the temperature and precipitation values and submit it, you will get the predicted bird count. And now, based on this predicted bird count, I have extracted all the bird species that lie within this region between the ranges of the temperature and the precipitation values that were entered by the user. Now click on a random bird name and submit it. Now you will get the output of the bird over here. So yeah, so that's the code for this part. So yeah, this is my project. Thanks for listening.